Hello and welcome back. It's been a while. Today we've got a new question involving pH and log laws. So one key piece of information we need is the pH equation, and that is pH is equal to the negative log base 10 of H3O plus. And that just is the amount of hydronium ions, or the concentration of hydronium ions in water. So question A, we've got the pH is 7. So we know pH equals 7. We can just sub that into our equation. So we can have 7 will equal log base 10, negative log, sorry, base 10 H3O plus. We want to just get the H3O plus on its own, so get rid of that negative sign. Negative 7 is equal to negative log 10 H3O plus. And then we want to get rid of that log, so 10 to the negative 7 equals H3O plus. And this just means that there is 10 to the negative 7 moles per liter. Moles is just a term for the amount of molecules of whatever particular molecule you're looking at, in this case hydronium. And that's question A done. The concentration is 10 to the negative 7 moles per liter. Question B now. So sorry, for question A, it's just a simple application of log laws. It looks a little bit complicated because you've got pH and H3O. But imagine if this instead said, let's use a different color for this. Imagine if this question just said y equals negative log 10 of x. And the question said, well, y was 7, find x. And that's exactly what we've done. It's just been wrapped up in pHs and H3O+. So the process is the exact same as this red text down here. Let's look at question B now. A solution is made by diluting 1 liter of acid. Okay. And it has a pH of 2. And we've also got 1 liter of water, and that has a pH of 7. So we know the concentration in this 1 liter here. We want to work out 1 liter of water. We want to work out the concentration of the acid. So again, this question gives us the pH. It tells us what the pH is. We could use that to find the concentration of hydronium. So let's do that. 2 will equal negative log base 10 H3O plus. Rearrange this, get rid of the negative sign. We'll have negative 2 equals log base 10 H3O plus. Get rid of that log base 10. 10 to the power of negative 2 equals H3O plus. So we know the concentration of hydronium ions now in the acid. It is a lot more than the water. Now if you add those two together, because you're pouring 1 liter of acid with 1 liter of water to get the solution, we want to find the pH of the solution. So if we say the acid plus the water will equal the solution, because that's what's happening. We're adding the acid and the water together. So the acid, that was 10 to the negative 2 plus 10 to the negative 7, and that would be the solution's amount of hydronium ions. So that is, if we just use a calculator, 0.010000, let me see, 2, 3, 4, 5, 6, 7. And that is moles. And this is per 2 liters, of course, because we've got 1 liter of acid, 1 liter of water. So we'll have 2 liters in total. The concentration is given per liter though. So we just have to make this into a per liter measurement. So we divide everything by 2. So that'll be 0.0050005 moles per liter. And let me just continue that up here. So that is the same as 5.00005 times 10 to the negative 3. So now we've got our concentration. This here is our H3O plus value. We want to find the pH. What is the pH? So here we've got our H3O plus value. We want our pH. So we'll just sub it into our pH formula. pH equals negative log base 10 of 5.00005 times 10 to the negative 3. And just putting that into the calculator, we will get 2.301, etc. And that's got an accuracy of 3 decimal places. And that's question B done. What is the pH of the solution? So this one we needed to add the two acids together, sorry, the acid and the water, get the total number of hydronium ions, and then realize, oh hey, this is actually 2 liters worth, but our concentration needs to be per liter. So we divided that by 2. Once we had that, we have to go back and sub it into our equation to get our pH, because that's our goal, getting the pH. And that's it for part 1 of this 2-part video. I'll see you next time for part C and D.